Okay, so this one over here, we have sine squared x over 1 minus cos x and 1 plus cos x. Notice that there's no signs on this side, but there's a sign on this side. So I probably want to get rid of the sign on this side. And I'm going to do that by doing the sine squared. I'm going to use the Pythagoras one again. So I'm going to say 1 minus the left side, sorry, is 1 minus cos squared x over 1 minus cos x. And this over here is a difference of squares. So I could write this as 1 minus cos x times 1 plus cos x all over 1 minus cos x. And then these guys are the same, so they could cancel. And that's going to give us 1 plus cos x. And the left side and the right side are the same. So left side equals the right side. I'm going to show a different way we could have done that one, actually. That's probably the way I just did it is the way I would do it. But let's say you let's say what you decide to do is you decide to work on the right side instead of the left side. So what we could see is we could see the right side. Now we wanted to make it look like this. So what I might do is I could take the 1 plus cos x, and I want to make it look like the left side. So what I could do is multiply it by 1 over cos x over 1 minus cos x. Because you definitely can. So then what we're going to end up with is 1 plus cos x times 1 minus cos x all over 1 minus cos x. We could FOIL this thing out. Right, so multiply that. And that's going to give us 1 plus cos x minus cos squared x, all divided, oops, I'm off the screen, all divided by 1 minus cos x. Those guys cancel. So we end up with 1 minus cos squared x all over 1 minus cos x. But 1 minus cos squared x is equal to sine squared x. And so therefore it is equal to it's equal to sine squared x over 1 minus cos x. That's the right side, which is the left side. So yet again, left side equals the right side. And there's just another way of proving the same thing. Okay, this one over here. They're both kind of ugly. I'm going to work on the left side first. So what I want here is I want to make a common denominator. Actually, I'm going to work on both sides for this one. So I have a tangent there, and I kind of want to get rid of that tangent. So I'm going to say, okay, tan of x is 2 sine x over cos x all over cos x, which you can work out for yourselves, is going to be 2 sine x over cos squared x. And I might stop there. I'm going to stop there temporarily. No one says you have to go completely there. So on the left side now, what I'm going to do is I'm going to find a common denominator. I'm going to do that by multiplying. So this one I'm going to be multiplied by 1 plus sine, 1 plus sine, 1 minus sine, 1 minus sine. So it's going to be 1 over 1 minus sine x times 1 plus sine x over 1 plus sine x minus 1 over 1 plus sine x. This is going to, squishing this in a little tight. I recognize that. So, what we end up with is 1 plus sine x over 1 minus sine x times 1 plus sine x minus 1 minus sine x over, there's a minus in a fraction, we got to be careful with that one, right? 1 plus sine x, 1 minus sine x. And these are not the same, right? This is left side, right side. So, are these common denominators? They are. They're in different orders, but it's the same thing. So it's going to be the top of this one, which is 1 plus sine x, minus the top of that one. Because remember, there's always invisible brackets around every fraction, around the top and the bottom. And all that is over 1 minus sine x times 1 plus sine x. We're definitely going to need a new page here. So we're still on the left side. So we're going to get rid of the brackets on that. And that's going to be 1 plus sine x minus 1 plus sine x. Then on the bottom, we're going to expand it. So we're going to FOIL this thing. So 1 times 1 is 1. 1 times sine is sine. Minus sine times 1 is minus sine. And negative sine times sine is minus sine squared x. Okay. So what we have here, I'm going to change. So what we notice is that first this bottom, these guys cancel. And for the top, we have 1 minus 1. So these guys also cancel. So that's going to give us sine x plus sine x over 1 minus sine squared x. Sine x plus sine x is 2 sine x. And 1 minus sine squared x is cos squared x. Is cos squared x. And if you remember, that's actually what so that was the left side was equal to that. The right side was equal to 2 sine x over cos squared x. The left side equals to the right side, which means the identity is true. And we are